Hi and welcome back to a new video. It's been a while that we featured something from the Thermal Grizzly production, but we have a very interesting machine coming today, which I just wanted to show you in terms of what we're doing. And I'm very looking forward to test this machine. I just want to explain what we're doing. So for every item that we're making in terms of mechanical components, for example, a CPU contact frame or even parts of a water block, we have to do surface treatment. So they come out of the CNC mill, and we are now in the room that we call the sandblasting room, even though it's not quite correct, because it's not sandblasting what we're doing, but we're using glass beads. Anyway, the goal is to have a perfect surface finish. So we get the parts out of a CNC mill, and you have naturally some CNC milling marks. There's no way to avoid that. But what we can do is do extra surface treatment, and that's what we're doing in this room. And historically, we've been using this machine, which is the T-Rex 140. It's a universal sandblasting machine with a rather huge chamber. I can also open this. I'm also pretty sure some of you have seen this in previous videos that I was doing. And what we have inside is two different ways to use this machine, so two different types. It's not sure what the English correct term is, but one is like injector blasting and one is pressure blasting, if I just translate it from German. And they just have different power, I would say. And what we're using is this stuff right here, which looks like dust. Those are very tiny glass beads, and they are pushed or blown onto the surface, and then they are cleaning the surface or they make the surface more uniform. And our goal is obviously to just deliver the perfect surface quality for each item. May it be a contact frame, a delitter, or like right now with the 5090 water blocks. And especially when we started doing the 5090 water block production, we quickly had to figure out that a contact frame that has small surface, small edges, is quite a different item to a 5090 backplate that has like this size, a very even surface, and you can quickly see surface defects or impacts from the manual labor that we are doing right here. So it's always a machinist that's in front of this machine, and then he's manually sandblasting the parts. Especially for contact frames, we made tens of thousands of items here manually. That all worked fine because it's an easy process, even though it's not nice in terms of working atmosphere. It's just not a nice job to do, but it has to be done. But with the 5090 backplate, the problem is it's a huge surface and it's quite difficult to have a very even surface finish if you're doing this manually. Especially after anodizing, we had to find out that with this process, we are not able to deliver the quality constantly that we're trying to deliver. So we had a lot of scrap that we had to sort out after the anodizing. And it was also just a long learning process for us to figure out what the issue was. So we just had the parts that looked nice after sandblasting, and then once they came back from anodizing, they didn't look nice anymore. And we were like, what's going wrong? Is this anodizing issue or what's the problem? And then we narrowed it down to this process. And we had to figure out that we need a new machine. And this machine was just delivered today, and it's very, very cool. Thermal Grizzly Duronaut is our new high-end thermal paste and the successor of Cryonaut. It's even better performing, it is much easier to apply, it is cheaper, and it's much more durable. That's where the name comes from. Especially if you're now maybe considering to buy a new PC, then I would highly recommend that you're looking into this thermal paste. So let's continue with this video. This is the machine I'm talking about. It's the Bernstein Twister. Bernstein is a German company. It's a brilliant piece of German engineering. I have to highlight that. I didn't even know it exists until a couple of weeks ago, but we were at a different supplier, a partner of us, and he had this machine and he was talking about how great it is. And then we just got in touch with them and quickly decided that we need the same thing for us. It's quite the opposite from sandblasting because it works in a vacuum. Now you might think, how does this even make sense? Well, first of all, in a normal sandblasting machine, you have the issue that you're using pressure, just air pressure, which is a super cost-intense medium. Like it's so expensive to make, just with the compressors and everything. And the problem is with sandblasting that you need high pressure to transport the glass beads, but at the same time you actually don't want to have a high pressure because the high pressure is also damaging the surface. So what you're doing is you're hitting the surface with the glass beads, and this is roughening the surface, which is nice for us in terms of getting the even look or design that we're trying to achieve. But at the same time, you're also compressing parts of the surface, so you're changing the crystalline structure of the aluminum, which is causing defects, especially after anodizing. And that's the issue we were facing with the 5090 backplate. Now, this machine is completely different. It uses a vacuum chamber inside. And there is like a rotating mechanism in the center where steel balls are being dropped down, like very tiny ones. And it's just spinning very fast and blasting the steel balls to the side. And because it's in the vacuum, they're not being slowed down by the air. And thus, it's just blasting the parts that are surrounding the middle piece. And in the center, you have like a carousel that is like rotating in like double or triple motion. So all the parts are always evenly hit by the steel bead. So that's the idea behind this machine. Opposite, you're saving a lot of money in terms of you're saving all the pressure, the air pressure that you don't need anymore, the pressurized air, and it's much more effective. It's much more even. It's partially automized, which is something our people will also love, because now we're changing from every single contact frame being manually sandblasted to just hooking up maybe 40 of the contact frames into the machine. You just press start, wait until they're done. And this should also allow us to increase the output of what we're doing in terms of products. Now the thing is, you can see it's in our warehouse. And it has to be moved inside the sandblasting room. And when I was buying the machine, I kind of knew that this might be an issue, but I was thinking the future Roman will take care of this. Now it's the day that the future Roman is here and has no clue how he's going to solve the problem. The thing is, this machine is 2 meters and 30 centimeters high. And the entrance, the door to our room is 2 meters and 10. So we somehow have to, partially disassemble the machine and deduct at least 20 centimeters to be able to put the machine inside the room. That's the challenge we're facing right now. We quickly saw that there are those two covers they look like they're stacked on top. And I hope that we can just remove these and thus reduce the height. So just the top of the machine, there's not much. I was hoping that there is something like a hook, so we could hook it up to the ceiling maybe and then flip it, but without anything to attach. And 750 to 800 kilograms, that's maybe not smart, but from just looking inside, seems like there's enough clearance that we could just take off the cover and then work on this. And just to show it again, that's the machine, full height. And this is the room it's supposed to go into. That's how the backplate looks like when it's coming out of the CNC mill. It still has a super nice surface finish, so you can see that right here. It's almost like a mirror finish, so the surface roughness is really good on the part. But we want to achieve this matte finish, and for this we just have to blast it. I probably can show you the result, how it looks like after the sandblasting, but also how it looks like when the result is not what you're trying to achieve. I wasn't able to find the backplate with the issue I was describing, but one of the 5090 frames, so aluminum frames. And if I tilt this, you can see somewhat like a camouflage pattern on this aluminum piece. And this is exactly what's happening. So after the CNC milling, it went into the glass bead blasting process. Everything looked fine. Then it went to anodizing, and in the anodizing process it's also etched at the same time. And the etching process is revealing this pattern. And this only happens if they have to etch really strong because of the different, I would say, surface compression that happened during the blasting process. And that's the issue we were facing. And especially if you think of, it's the last step in production, right? So you're spending a lot of time and money into machining these complex parts. It's very expensive, and then it's basically considered scrap after the last step, which was plating. So we're first removing just the cover on top and then those additional two things, and that's hopefully enough without having to remove the engine that's sitting inside. That should just work out, I think, in terms of height. Glad that that was a quick and easy fix. without having to disassemble the entire machine. Meanwhile, almost a week later, and the machine is almost at a place where it's supposed to be. There is still a bit of space behind the machine to the wall, but we're waiting for the technician from Bernstein to come here and just get the machine running with us. And it's already sort of running, so I already switched it on. And we can also take a look inside in a second. And here we have the filter machine that is also next to it. Still has to be attached with the tubing and some wiring, but it's also what the technician is supposed to do tomorrow. The inside is very interesting, and there's also something I have to make clear, because I just realized that at the beginning of the video I was mistaken in what I said, because my first assumption was that the powder will be dropped from the top and then there's this spinning disc, and I thought it will just drop down and through the spinning disc be blasted onto the parts. But then I looked at the spinning disc, so if we just film through the bottom, like right here, you can see there is no hole or anything like that. So I was like, how does this work? Like, where does the powder actually come from? And I think the powder comes from the bottom, like from here. And that probably just makes sense because the machine will be using vacuum, right? And the vacuum inside the machine will probably pull the powder with some air inwards, and then it's hitting the wheel on top, the flywheel, and this is then just blasting the parts just by rotation. And also you can see there is this triple gear, you could probably call it. So this outside ring is static, and the inside ring, the inside stainless steel ring, is rotating. And then you have those triple gears right here. So this gear is rotating through the static outer one, around this static one with this one that is rotating. So you have this super nice motion that's making sure that the part will be hit from all directions. And we have these fixtures right here, and for example, I added a contact frame on top. Of course, you could add more, like depending how you just design your fixture, then you could add, for example, 4 of the contact frames at once, and then it's simply just plugged on top here. And the entire chamber is also coated with something that feels like a rubber, which makes sense because we don't want to blast the inside of the chamber, and once the steel balls, they just hit the side, hit the wall, it will just be reflected by the rubber. And we also already received 75 kilograms of the steel balls, and we will have to fill them into the machine tomorrow. Now you can see the spinning motion, and you can just pay attention to the contact frame that's spinning around in circles right there. And you can see that by this triple sort of rotation, we will make sure that it's being hit from all directions just by the stuff that's coming from the center. Meanwhile, again, a couple of days later, and as you can see, the machine changed because we already started using it. There was a technician here from the company and just gave us a nice introduction, explained everything. I also now understand the machine much better in a lot of details, and we are still working on, just making the process perfect, fixtures and everything. So there's still a way to go, but it's already so nice to use this. For example, here we have the 5090 cold plate, so the big one that's made from copper CNC milled and has to be surface treated to get this very nice and even smooth finish. And for this, Joe created those fixtures. So they are 3D printed. We still have to optimize this a little bit, just play around with the center where it's rotating and just get them a little bit out of center. That's something we figured out to just reach all areas perfectly and just get a very, very nice surface finish. I just removed these surface covers right here so we can take a look inside the machine on the bottom. So sometimes helps to understand how it works, also helped me to understand and get a better idea of how this machine works. Because like at the beginning, as I said, some things were not that clear. So there's still something like a huge pump inside here that's pumping air. And that's absolutely relevant to understand how the steel balls or steel beads are pushed into the machine. So we have this thing where air tower is written on it, and that's like a big vacuum pump that it's pulling the vacuum constantly through the machine, like through the chamber in the back, and is constantly removing the air and thus creates a vacuum inside. And what you can see right here, that's like grayish stuff, gray powder, that's the steel balls or steel powder we're using for the surface treatment. And it just drops down to this opening. And that's where it comes down into this small tube or pipe. And this is like a Venturi nozzle and the pump is constantly pushing air through, and through the Venturi nozzle, it's sucking in the steel powder and then just pushes it up into the chamber. And that's how it comes out of this small hole, and then it's pushed onto the flywheel and then pushed to the side. It's again a few days later, and we've been using this machine successfully already in mass production. I'm just adding a new batch of the 1590, we call it frames, for the 1590 blocks of the outer aluminum frame into the machine. You can also see we removed some of these gears. So originally we had 10 spots in there, but that's just too much for the frame of the 1590 or even the 1590 cold plate, the big copper part. They're too big. So we had to take out half, but it still gives us 5 pieces simultaneously, which is absolutely nice. Then we are using these fixtures that we 3D printed, and they also work super nice. It's very cheap to make them. If something goes wrong, just print a new one. And also the material, if it hits because I think it's TPU, so it can withstand quite a lot because it's like flexible rubber almost. And if the steel balls hit the surface, they just get reflected to a certain degree. And then that's how we use it. So just put it on, add it to one of the wheels. Also, the position doesn't matter, so just randomly add it very fast, and then you're almost ready to go. I have to admit that with all 5 of these inside, it looks a bit scary. Sometimes you're just thinking it's going to hit each other, it's going to hit something on the side, on some of those gears, I don't know. But Joe just rebuilt this inside CAD just to make sure that we have enough clearance. He simulated everything. He made the fixtures accordingly, so everything is nice and will work out. So what's also absolutely nice about the machine is that you can program multiple steps. So we just start with one step with very high RPM of the wheel in the center, which just leads into a more rough surface finish. And then we go down in RPM and go down again. And then in the end, you have a very nice and even surface finish. And I guess we just close the machine now and give it a go. And with this batch is successfully surface treated. And this is the result afterwards, which is just a perfect uniform surface treatment. I'm so happy with this machine and also looking forward to the results after anodizing. This should definitely improve the quality that we're trying to deliver. The cool thing is especially the speed. So previously it took us about 10 minutes per piece manually, and now we're running 5 pieces in 15 minutes, so it's speeding up production quite a lot. I already just finished the next batch, going to replace these and keep on producing. And it's actually a lot of fun to use the machine. I also hope you had fun with this video, which was a bit different than the usual content you're seeing. Just leave me feedback down below if you like this kind of content and maybe you want to see more in the future. Thanks for tuning in. See you next time. Bye bye.